All right, we've made it. It's been a very long school year and there have been a lot of videos, but this is the last video. So congratulations before we even go any further on making it this far into the class, okay? In this video, what we're gonna do is we're gonna look at 3 example problems using the strategy that I developed in the last video for solving probability and counting problems, okay? Of course, I'm also assuming in this, not only that you've watched the last video where I outlined this strategy, but I'm assuming as well that you've watched the previous videos that talk about like, how do you use the fundamental counting principle? How do you do a permutation and those kinds of things? So if you haven't watched any of those videos, you're not quite sure how to type something into your calculator or any of those other details, you may need to go back and watch those videos in addition to this one. All right. So with that said, I'm going to switch over to my piece of paper and we're going to wrap up the school year by continuing this discussion that we started last time. All right. Developing a strategy for solving probability and counting problems. That's what we're talking about. We said that this is built off of our old strategy that we've had all year long, 5 steps for solving problems. You've got to understand the problem. You've got to organize your information, develop a plan, and then you actually do the problems. Not to way down here that you actually do the problem. And you'll see when we do these examples, this is true in general, but it's especially true for these types of problems that this right here is like 90% of the work. Actually doing the problem and getting the answer is very, very little work on these problems. You've got to go through this process if you want to have any hope of getting to a right answer. Okay. All right. So let's go ahead and use this strategy that we developed in the last video. It's based on a combination of thorough understanding and then answering a series of questions to help us put a plan in place. Now, for these particular problems, they tend, as we know, they tend to all be story problems. They're kind of wordy. And so what I've done is I've found a couple problems from some old textbooks. This is a textbook that we used in our Algebra 2 class. Actually, we still use it a little bit, but it's by Dr. Larson and a couple other people. It's a pretty popular high school Algebra 2 book. And I am going to choose this problem right here. This problem actually had a part A and a part B. That's why I've got the sticky note here. I'm just going to take a look at part A, and this is the problem that we're going to do first. Okay, so this is a license plate problem. Well, we've seen something like this before. This one's a little different, but we've seen something like this before. It says in some states you can buy a personalized license plate. It wants us to know how many personal license plates are possible if the license plate follows the pattern of having 3 digits followed by 3 letters. Okay, so that's exactly what we see in the picture here. There's 3 digits. Okay, digits means a single digit number. That's what they mean by digits. And then there's 3 letters. Now, they don't say any other restrictions. So for the purpose of this problem, we're going to assume the only restriction that's on us is that you must start with 3 single digit numbers and you must end with 3 letters from the English alphabet. Okay, so if we make that assumption, now we can start going through the process. Oh, as a side note, for the purposes of taking notes, if you're going to use this video to take notes, you might want to pause the video real quick and write this down so that you can refer back to the problem when you're studying for your quiz or just in general. Okay, so first thing I need to do is thoroughly understand the problem. And I think just simply by summarizing the problem, I think I've done that. I've got a license plate. It's going to have 3 numbers. It's going to have 3 letters. Those are the only restrictions that are on me. The question that they're asking me is to find how many plates are possible. So this is not a probability question. It doesn't say find the probability of something. It wants to know how many license plates are possible. So this is a counting question. So when it comes to our little outline here of different questions, the first thing I need to make sure is that I understand that this is not a probability question. I'm not using this fraction, all right? Instead, what I'm going to do is jump ahead to figuring out what's important here. Well, I think what's important as far as numbers and things are concerned is that I'm going to have 3 digits, 1, 2, 3, followed by 3 letters. 1, 2, 3. So that's a total of 6 slots altogether. All right. So that, I think, takes care of understanding the problem and finding the important numbers in the problem. Now let's go to what our questions were. So we said we wanted to ask some questions. Okay. So we found the problems. The numbers that are important, 3 and 3, those are our 2 important numbers. Let's go through and ask some questions. Now, we're going to only need to ask these questions once because we're not working with probability. Remember, we said we only will ask the question twice if it's probability because we have to do the top and the bottom separate, but we're not doing probability. So here are our 3 questions. Are there multiple events that are always occurring? Okay, well, let's think about making a license plate. When I make a license plate, what I need to do is I need to choose some number or some letter and print that thing on the license plate. And I'm going to need to go through that process of choosing a number or letter and printing it on the license plate over and over and over again until I have a full license plate. So I think the answer to this question is that yes, we do have multiple events. And specifically, the event is when I choose a letter or choose a number. So this is a yes. All right. So that means keep asking questions. Question 2, are there replacements? So remember, when they ask, are there replacements, what that's asking us is it possible to use the same thing more than once? Okay. So maybe I should pause for a second and give you time to think about it. In this story, in this context, on this license plate, is it possible to use the same number or the same letter more than once? I think the answer to that question is yes, right? The story did not tell me that I'm not allowed to repeat. And we said we were going to assume that there's no other restrictions besides just the fact that it's 3 numbers followed by 3 letters. So I think the answer to this question is yes, we're allowed to have repeats. We're allowed to have replacements. So that tells me use fundamental counting principle. So I don't need to ask any more questions. I'm done. I know I'm going to use fundamental counting principle. So let's start to set that up. Okay. If you recall from our lesson on fundamental counting principle, what that says is that for every event, and we said our events were going to be picking letters and picking numbers, right? And so our license plate has to have 3 numbers followed by 3 letters. Okay, so our event is going to be pick a number, and then our second event is pick a number. Our third event is pick a number. Our fourth event is pick a letter. Fifth event is pick a letter. Sixth event is pick a letter. Okay, now what we're supposed to do, according to the fundamental counting principle, is once we know how many ways to do each one of the events, we're going to multiply those all together. But the challenge that I have before me right now is I have to figure out how many ways to pick a number. All right, so let's think about what are the numbers. Well, there's the ones that we all think about when we think about single digit numbers. There's these, but it didn't give me any restrictions. So I think there's one more single digit number that we have to make sure we remember, and that's this one. So altogether, how many single digit numbers do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've got 10 single digit numbers. So how many options do I have when I pick a single digit number? I've got 10 options. The next time I pick a single digit number, remember, we're assuming that replacements are okay. So even, if I put a 2 in the first spot, I can still pick a 2 again for the next spot on my license plate. So I think I have 10 options still. And then that would be true for the third spot, still 10 options. Okay, now I'm done picking numbers. Now I have to pick letters. So for each of these spots, I have to pick a letter. So there's A, B, C, D, right? All the way to X, Y, and Z. How many are there all together? There are 26 letters in the English alphabet. Altogether, there's 26 letters. So when I pick a letter, how many options do I have? How many different letters could I potentially pick? How many different outcomes are there? Well, there's going to be a total of 26 different outcomes. So that's what's going to go here. Then the next time I pick a letter, remember, we're assuming that replacements are okay. So there's 26 options for here. And the last time I pick a letter, replacements are still okay. So there's 26 options for there. All right. So this becomes the number of ways I can do each event. And according to the fundamental counting principle, my answer should be what I get when I multiply all of these together. So I have 10 times 10 times 10, and then times 26 times 26 times 26. And there's the total number of license plates that we could potentially have. Okay, so 1757600, 17,576,000 license plates. Now, let's be honest. In real life, that's not the right number, because in real life, states have other rules, right? There are restrictions on this, right? There are certain letter combinations that I'm not allowed to put together. Because they spell bad words or something like that, right? So there are other restrictions in real life that states put on license plates, but with the problem that we had, with the assumptions that we made, this is how many license plates that I could potentially put if I have 3 numbers followed by 3 letters. Okay, so that's our first example. That's example number 1. For example number 2, again, I'm going to take a problem out of this exact same textbook. Okay, here's the problem down here. It's a probability problem this time. Okay, so it says find the probability of, and then the one that I've got 3 problems here, you can see. The problem that I'm going to do is problem number 1. Problem number 1. So if I read the whole thing, I've got to read the directions and this also. Okay, so it says, a card is randomly selected from a standard deck of 52 cards. Find the probability of the card is an ace or the card is a jack. All right, so if you want to write that in your notes, pause the video right now and get that written down in your notes. Now that you've got that written in your notes, I'm going to go through the exact same steps. Now, this time my questions are going to have different answers. So the way I'm going to actually do the problem will be different, but I'm going to go through the exact same steps for this question. Okay. So maybe what you should do is, as I approach each step, maybe you should pause the video and try the step first. So the first step is to understand the problem and the question. So maybe pause the video and take a minute to make sure that you understand. All right, so the problem, what's happening is I've got a deck of cards, and I know something about deck of cards, and in a previous video, we talked about this. There's 52 cards. The 52 cards are divided into 4 suits. 2 of the suits are red, 2 of the suits are black. Every suit has 13 cards in it. The cards start with ace, which is the number 1, and they go all the way up to king, and we go from there. Okay, so there's facts that I know. And I'm picking a card at random from the deck. So that means I can't see the cards. Somebody has shuffled them all up. I'm just picking one out of the pile. Okay. The question, I'm calculating a probability. So I know I'm going to use my fraction. And I'm trying to find the probability that the card is an ace or a jack. So again, remember, I've got an ace in every suit, and there's 4 suits. And there's a jack in every suit, and there's 4 suits. So there's 4 aces altogether, and there's 4 jacks altogether. So that's, again, and I'm almost bordering on starting to organize data right now, but that really is still understanding the problem, understanding that there's an ace of hearts and an ace of spades and an ace of clubs and an ace of diamonds and so on. Okay, so there we go. I've got all that. Now, the next thing is to organize my numbers. Well, they didn't give me any numbers other than that there's 52 cards. That's the only number they gave me. I know from personal experience that there's 4 aces and there's 4 jacks. So I guess those are other numbers that are going to be important to me. Okay. Now look ahead over here for just a second. We're not doing problem number 2. But if we were doing problem number 2, notice that one of the things that we're trying to pick is a 7. Would the 7 be important to this problem? In other words, when we calculate probability, will we put 7 into our equation somewhere? The answer to that question is no, we wouldn't. Because 7 is just the picture that's on the card. It's no different than having a jack on the card or an ace on the card. So this would be an unimportant number. Whereas over here, the really important numbers aren't even given to us. We just have to know there's 4 aces and there's 4 jacks. So that's another one of the tricky things with these types of problems. All right, so we understand the problem. We've found our important numbers. The next thing to do now is to start organizing the concepts of this problem by asking some questions. And depending on the answers to these questions, that's going to determine our plan. So the first question is, are there multiple events that always occur? So here I'm drawing cards. Okay, so I guess you could say that's one event. But more importantly, when I think about the number of desirable outcomes, when I think about the top of my fraction, in the top of my fraction, what I'm really figuring out here, and because remember, we have to ask these questions twice, once for the top and once for the bottom, okay? In the top of my fraction, I have an outcome of getting an ace, and I have an outcome of getting a jack. That's 2 different outcomes. Do they both occur? And the answer to that question is no, they don't both occur. It says ace or jack. It's not both. It's one or the other. So because I have this word or, when I do the numbers on the top at least, I cannot use any other method other than to literally count, because that's the only way we've learned in our class how to handle the word or, is I have to literally count. Okay, now what about the bottom of my fraction? In the bottom of my fraction, I'm trying to calculate the total number of possible outcomes. Okay, so are there multiple events in the story when I'm thinking about the total number of ways I can draw a card? Well, the answer to that question is also no, because I'm only drawing one card. So are there different ways that that can happen? Sure, because there's different cards in the deck. But it's still only one event. You pick a card. That's it. That's all that's happening. So for both the top and the bottom of my fraction, I'm going to literally count. So this is a problem where it turns out that I can use the same method for the top and the bottom both. That's not always true, but it is true on this problem. As a side note, it just occurs to me that's also going to be true on the next problem that we do, but that's not always true. Okay, so here we go. I know that probability is equal to the number of desirable, I'm just going to put des for desirable outcomes, and the total number of outcomes. That's the fraction I've got to make. All right, so let's think about this. We have to just literally count these things. So it said I can either get an ace or I can get a jack. Those are my desirable outcomes. I get an ace or I get a jack. So we've already said we know there are 4 aces. So there's 4 possible outcomes: ace of diamonds, ace of hearts, ace of clubs, ace of spades. That's 4 possible outcomes. There are also 4 jacks. So jack of diamonds, jack of hearts, jack of clubs, jack of spades. There's 4 jacks. So altogether, how many outcomes are desirable? Well, there's the ace and the jack of hearts. That's 2. Ace and the jack of diamonds. That's 4. Ace and the jack of clubs. That's 6. Ace and the jack of spades. That's 8. So altogether, we have 8 desirable outcomes. Okay. Now, total possible number of outcomes. There's a deck. It has 52 cards in it. I'm going to pick one of the cards out of the deck. I could get any one out of the 52. So I think that means I've got 52 options. That's my total number of possible options. Okay. So now I just grab my calculator and I simplify 8 divided by 52. And my probability is going to be approximately 0.15. And round off to whatever the directions on the quiz or the worksheet or whatever say. So I'm just going to round off to 3 places, 0.154. There's my probability. So remember, probability could also be expressed as a percentage. So this would be about 15% of the time I can expect to get either an ace or a jack. Okay, so that's example number 2. That's example number 2. And that leaves us last with example number 3. Now, example number 3, I'm moving to a slightly different book. This book also, incidentally, happens to be written by Dr. Larson, but it's with some other person and not the same people as the last book. And this is a more advanced algebra book. This is technically a college book, but the problem that I've selected from here is one that we can handle. Okay. It is also a problem that has like a part A, part B, part C. You can see it's a college book, right? Because it's a lot less pictures, a lot more words. Okay. This also had a part A, part B, part C, but we're only going to just look at just part A is all that we're going to look at here. And it's this problem right here that's number 50, problem number 50. So again, you may want to pause the video for a second and copy this problem into your notes. All right, now that you've got that copied into your notes, the next thing you should do is take a minute to make sure that you understand the problem and understand the question. So pause the video real quick and reflect. What is the problem and what is the question? How would you summarize the story and what question are they asking? All right, so hopefully you've done that. So let's start with the story. The story says I've got a shipment of 20 compact disc players. This is an old book, apparently. You might not even know what a compact disc player is. All right. So this is what we had back before we had MP3s that we could download, or this is how we used to listen to music back in the olden days. All right. So this is like when I was in college. This is what I listened to. All right. So compact discs. All right. So we've got a shipment that has 20 compact disc players, and 4 of them don't work. There's 4 defective units. Okay, that's unfortunate. Now, notice that it doesn't say anything about which ones are good or which ones are bad. So right now I'm going to have to make an assumption about this problem. I'm going to assume that we can't tell them apart. They're in the box. They all look the same. The only way to know which ones work and which ones don't work is to plug them in. And of course, you can't plug it in until after you buy it, right? So here we've got a store, and they're going to buy 5 of these compact disc players. So there's 20 altogether. We're buying 5 of them. And out of the 24 don't work. So you can kind of imagine this is kind of, a little bit of, there's a chance that we might pick one of the ones that doesn't work. There's a chance. In fact, that's the probability that they're asking us to do. Find the probability that we only get ones that work. So what's the probability that we're lucky? What's the probability that we don't end up with something that's broken? Okay, so that's what we're shooting for. What's the probability that we don't get something that's broken? All right, now because of the question is probability, that tells me I'm going to use my fraction. I'm going to use my fraction again. So that's, I know that's going to be part of my plan is to use my fraction. And because I'm using my fraction, that means when I go through and I start asking my questions, I'm going to have to ask all the questions twice. Once as I think about the top of my fraction, and once as I think about the bottom of my fraction. All right. So with that as a backdrop, with that in mind, let's start working through the problem. So now that we've discussed that we understand it, the next step is to find the important numbers. That shouldn't be too hard for you. Take a second real quick to do that. All right. So it seems to me the important numbers are the fact that there's 20 altogether in this shipment. We're going to buy 5 of them. There are 4 in the shipment that are broken. Okay. Now that does mean there's one other number that's not printed here, but might be important to me. If there are 4 in a shipment out of 20, if there are 4 that are broken, how many of them are not broken? Since we're trying to figure out the probability that we only get things that are not broken, it might be important for us to know how many are not broken. So once again, notice there's a number in this problem that's an important number, and it's not written here. The number that are not broken would be 20 minus 4. It would be 16. All right. So make sure that you're comfortable with that idea. All right. So we know this is probability. We figured that out. We've found our important numbers. Now it's time to start asking our questions. And we're going to have to ask our questions for the top and for the bottom separately. So number of desirable and total number. Okay, we're going to have to do those 2 things separately. I personally, I don't know why, just over the years I've developed the habit. I like to do the bottom number first. I don't know why. Okay, so total number. So what we have in the bottom, well, again, maybe you need to pause the video and think about this for a second. In the context of this problem, total number of what? What is the total that's going in the bottom? Okay, when we say find the probability and the top is desirable outcomes, and the bottom is total number of all possible outcomes, what are the outcomes even? What are we talking about? What are the outcomes here? So maybe see if you can think of that. All right, it seems to me the outcomes are the numbers of different ways that we can buy 5 CD players. So we might buy 5 CD players that work. That's what we desire. But I might buy 4 that work and 1 that's broken, or I might buy 3 that work and 2 that are broken, or whatever. Okay. So I think total number is all the different ways that we could buy 5 CDs, all the different combinations or permutations or whatever they are. We'll figure that out in a second. But all the different ways that we can end up with a mixture of broken and not broken CDs. I think that's what's going in the bottom. Okay. So that's my first thing that I understand, is that I have a total number of mixtures of broken and not broken CDs. Okay, so that's what I'm trying to figure out in the bottom. Now, in that, do I have multiple events that always happen? And I think the answer to that question, well, let me pause and give you a chance to figure out the answer to that question. Are there multiple events that always happen? When we consider the total number of possible events, I think the answer is yes, because we're buying 5 units, right? We're buying 5 units. So because we're buying 5 units, we've got 5 different things, right? We've got unit number 1, unit number 2, unit number 3. We've got 5 different things. So I think there are multiple things that are happening, and they're happening every time. So that's our first question. So it says, if the answer is yes, then make sure you know what the events are. Okay, so the events are that we're buying a unit. And then it says, now keep asking questions. So I'm looking at my flow chart over here. I don't want to just keep back and forth. So you've already got this flow chart in your notes. Maybe you want to look at it too. The next question asks, are there replacements? Are there replacements? So think about that. Have a solid answer in your mind. Are there replacements? I think the answer to this question is no, right? I don't know about you, but when I buy something at the store, I don't want to have to pay for something to buy it and then turn around and have to pay to buy the exact same thing again, like literally the exact same thing. Like I just bought a candy bar. I ate half of it. Now I'm going to buy the exact same half of a candy bar again. I'm not going to do that, right? I already paid you once for this candy bar. I'm not going to pay you again. So I think this is a problem where there's no replacements. Once we buy a CD player, that CD player is ours. We're not going to put it back and buy it again. So there are no replacements. So the question says, if there are no replacements, then keep asking questions. So here's the last question. Does order matter? So when we think about, remember, what we're looking at is I'm buying a CD player that's either broken or it's not broken. So when I get ones that are broken, and when I get ones that are not broken, does it matter what order I buy those CD players in? I don't think it does. Bottom line, all I care about is whether or not it's broken or not. So I think this is a situation where order does not matter. So according to my little questions here, if order does not matter, I'm going to use a combination. So in the bottom of my fraction, I've now decided I'm using a combination. I'm using a combination. So what will be the 2 numbers? Well, remember the first number in the combination is the number that represents all the things in the group that we're choosing from. So how many things are in the group of CD players that we're choosing from? I think it's 20. And the second number represents the number of things that we're choosing from the group. So how many CD players are we actually buying? I think it's 5. So the bottom of my fraction, I think, should be 20 combination with 5. Okay? And in a minute, we'll type that into our calculator. Now, we've got to go through all those exact same questions again for the top. Now, here's what I'm going to do. I just modeled that very slowly for the bottom. I'm going to ask you pause the video right now and go through all of those questions for the top and resume the video once you have written something here. So once you know what's going in the top, then press play and start the video back up again. All right. So hopefully you've got a number right here. What I'm going to do is I'm just going to roll through those questions relatively quickly because hopefully you've already thought all these through. So the first question I'm asking myself, is, are there multiple events? And the answer to that in my mind is still yes. I'm still buying 5 things. I'm just hoping now that all of them work. I'm not worrying about the ones that are broken, ones that are not. I'm just hoping that they all work. But I'm still buying 5 things. I still have multiple events. So that's yes. So the next question, are there replacements? I think the answer there is still no. There are still not replacements. I'm not going to buy something twice. And that moves me down, does order matter? And I think especially if they're all identical CD players and they all work, I'm not sure I can even tell what order I bought them in. So order absolutely does not matter. So I think this is once again a combination question. This is a combination question. Okay, now I have to find the 2 numbers that go here. And if you haven't found those 2 numbers yet, maybe pause the video again real fast and get those 2 numbers. So the first number is how many I can choose from. Now here's where the problem changes a little bit. Down here, there were 20 because I was buying from the whole entire shipment. This was the total number. And my shipment had in total 20 CD players. But now, desirable outcomes, I'm only buying ones that are good. That's it. I'm only buying ones that are good. So how many did we say were good? Well, 20 minus the 4 broken ones, there are 16 good ones. And so that's the number that's going in front of my C. I'm still buying 5. That hasn't changed. So that's the number that goes in the back of my C. And now there's the problem as I'm going to type it into my calculator. So let's do that. So in the top of my fraction, I've got 16. And then wherever it is that you find your combinations feature. So 16 combination with a 5, big number, 4,000 something. In the bottom of my fraction, 20 combination with a 5. Also big number, 15,000 something. And so my probability is going to be the good numbers divided by the total numbers. And there's my probability. I've got about a 28% chance. But I'm going to write my answer as a decimal. So for my answer, I'm going to write 0.28. And again, I'm just going to round off to 3 decimals. On the test or a quiz, just follow whatever the directions tell you to do. All right. So there's my 3rd example. So that takes care of this particular video. Thanks for watching. Have a good one.